All right, so picture this. You're standing on a windy beach. A crazy contraption of wooden fabric is sputtering in front of you, and everyone thinks you're, well, a little nuts. That was the reality for the Wright brothers. And today, we're going to go on an epic journey. Welcome to our channel. Today, we're diving into the fascinating world of air transportation and how technology has revolutionized it from the days of the Wright brothers to the era of autonomous planes. It's a story packed with genius, a fair bit of hold my beer and watch this moments, and some seriously cool engineering. We're talking about how we went from barely getting off the ground for 12 seconds to casually sipping tomato juice at 35,000 feet, crossing continents in a matter of hours. Think about it. Your great-grandparents might have thought a trip across the country was a monumental undertaking, and now we can hop on a plane and be there before dinner. That's not just progress, that's a quantum leap in how we experience the world, all thanks to some brilliant minds and a relentless pursuit of what if. And the story isn't over, not by a long shot. We're now on the cusp of another revolution with AI and autonomous systems potentially changing everything we thought we knew about flying. So buckle up, because we're going to explore the incredible milestones, the mind-blowing tech, and the sheer audacity that took humanity from dreaming of flight to mastering the skies. This is going to be awesome. So let's rewind the clock, way back, before your fancy smartphones, before the internet, heck, even before sliced bread was a big deal. We're talking about the early 1900s, and these two brothers, Orville and Wilbur Wright, they had this, let's call it an ambitious hobby. Most people were probably content with, horses and buggies, but not these guys. They looked up at the birds and thought, hey, we can do that, which frankly is the kind of slightly delusional optimism that changes the world. They weren't just dreamers, though. They were serious engineers, even if their workshop was a bicycle shop. They meticulously studied how birds flew, the shape of their wings, how they controlled their movement. They built gliders, hundreds of them, testing and tweaking, crashing and rebuilding. Imagine the patience. I get frustrated if my Wi-Fi drops for 30 seconds. These guys spent years, actual years, failing over and over again, learning from each face plant into the sand. That's dedication, folks. Their big challenge wasn't just getting airborne, it was staying airborne and crucially controlling the darn thing. They figured out this concept called wing warping, which is a super clever way to twist the wings to steer, kind of like how a bird subtly adjusts its feathers. This was a game changer. They also realized they needed a lightweight engine, something that didn't exist at the time. So what did they do? They built their own. With the help of their mechanic, Charlie Taylor, they cobbled together an engine that was just powerful enough and just light enough. Then came December 17th, 1903 at Kitty Hawk, North Carolina. The wind was whipping, it was cold, and the odds were probably still stacked against them. Orville climbed aboard the Flyer, this rickety-looking machine. The engine sputtered to life, it trundled down a makeshift track, and then, for 12 glorious seconds, it was actually flying. 12 seconds, that's barely enough time to skip a YouTube ad these days, but in those 12 seconds, covering just 120 feet, they proved it was possible. Humanity could fly. Think about the sheer guts that took. No flight simulators, no advanced materials, just wood, fabric, wire, and an unshakable belief in their calculations and designs. They weren't just inventors, they were pioneers in the truest sense of the word, venturing into a completely unknown territory. Their success wasn't just a personal triumph, it was a spark that ignited a global obsession with aviation. Suddenly, the sky wasn't the limit anymore, it was the next frontier. All right, so the Wright brothers got us off the ground. Fantastic. But those early planes, let's be honest, they weren't exactly speed demons. Propellers are great, they did the job for decades, but there's a limit to how fast you can spin a blade before things get complicated. Humanity, being humanity, immediately started thinking, okay, this is cool, but how can we go faster? And that, my friends, is where the jet engine struts onto the stage, looking all sleek and powerful. The concept of jet propulsion wasn't entirely new. Think of a deflating balloon zipping around the room. That's the basic idea. Newton's third law for every action. There's an equal and opposite reaction, but harnessing that for an aircraft, that was a whole different ballgame. It took some serious brainpower from folks like Frank Whittle in the UK and Hans von Ohain in Germany, working independently in the 1930s. These guys were the rock stars of a new kind of engine. Instead of propellers pulling the plane through the air, a jet engine sucks air in at the front, compresses it like crazy, mixes it with fuel and then ignites it. Kaboom! This super hot, super fast jet of gas blasts out the back, thrusting the plane forward at incredible speeds. It's like a continuous, controlled explosion. How cool is that? Suddenly, the sound barrier wasn't just a theoretical concept, it was a target. The first jet-powered flights happened in the late 1930s and early 1940s, primarily for military purposes during World War II. The Messerschmitt May 262 and the Gloucester Meteor were some of the first operational jet fighters, and they were a terrifying revelation on the battlefield. They were so much faster and could fly so much higher than propeller planes. It was like bringing a sports car to a horse race. This new technology completely changed the game for military aviation. But the real revolution for US regular folks came after the war, when engineers started thinking about putting these powerful new engines on passenger planes. The de Havilland Comet in 1952 became the world's first commercial jet airliner. Imagine going from a noisy, vibrating, relatively slow propeller plane journey to the smooth, quiet, and incredibly fast experience of a jet. It must have felt like stepping into the future. London to Johannesburg in under 24 hours? Unheard of. Of course, there were growing pains. Early jet engines were fuel guzzlers, and there were some tragic accidents as engineers learned the limits of this new technology and new flight envelopes. The Comet, for example, suffered from metal fatigue issues due to the stresses of high-altitude pressurized flight, something that wasn't fully understood at the time. Chapter 3: Breaking Barriers, the Sonic Boom and the Concorde Dream. So we've got jet engines, and they're making us go super fast. But you know, engineers, super fast is never fast enough. The next big, audacious goal: flying faster than the speed of sound. We're talking Mach 1, baby. That's around 767 miles per hour at sea level, though it varies with altitude and temperature. Breaking this sound barrier wasn't just about speed. It was about conquering a mysterious and, at the time, pretty scary aerodynamic phenomenon. Pilots in World War II diving their propeller planes too fast reported violent shaking and loss of control as they approached the speed of sound. Some even tragically broke apart. This led to the idea of a barrier, an invisible wall in the sky. It took incredible courage and some serious engineering to punch through it. Chuck Yeager, in the Bell X-1 rocket plane in 1947, was the first to officially do it. And that iconic sonic boom announced to the world that we'd entered a new era of speed. Now, flying faster than sound is one thing for a military test pilot in a tiny rocket plane. But what about doing it with 100 passengers sipping champagne? That was the dream behind supersonic transport, or SST. The most famous and arguably the most beautiful example of this dream was the Concorde. Developed by the British and French, this needle-nosed marvel was less a plane and more a work of art that could fly at Mach 2, twice the speed of sound. Imagine this: you could have breakfast in London, hop on the Concorde, and arrive in New York you technically left, thanks to the time difference and the sheer speed. New York to London in under 3 hours. That's faster than some people's daily commutes. For a select group of business travelers, celebrities, and the very wealthy, Concorde wasn't just transportation, it was a time machine. It was the absolute pinnacle of luxury and speed. The engineering behind Concorde was breathtaking. Its delta wings, the ogivale shape, were designed for optimal performance at supersonic speeds. The nose drooped down during takeoff and landing so pilots could actually see the runway, then tilted up to become more aerodynamic in flight. The engines, Rolls-Royce Olympus 593S, were incredibly powerful turbojets with afterburners basically injecting fuel directly into the hot exhaust for an extra kick, like a fighter jet. But flying at Mach 2 creates some unique challenges. Chapter 4: The Modern Marvels, Your Friendly Skies Optimized. Okay, so supersonic travel with Concorde was amazing, but for most of us, our experience with flying is the modern commercial airliner. The Boeing 737S, 787 Dreamliners, the Airbus A320S, A350S, and the mighty A380S. these planes might not break the sound barrier, but they are absolute marvels of engineering, designed for three crucial things: safety, efficiency, and passenger comfort. And let me tell you, the amount of tech packed into these things is mind-blowing. First up, safety. This is, without a doubt, the #1 priority in aviation. Modern commercial aircraft are arguably the safest mode of transportation ever invented. This isn't by accident. It's the result of decades of learning, rigorous testing, redundant systems, and incredibly stringent regulations. Think about it. Every critical system on a plane has backups, and sometimes backups for the backups. We're talking multiple engines, any of which can typically keep the plane flying, multiple hydraulic systems, multiple electrical systems, multiple navigation systems. The materials used are also incredible. Lightweight composites like carbon fiber reinforced polymers make up huge portions of modern aircraft like the Boeing 787 and Airbus A350. These materials are stronger and lighter than traditional aluminum, which means better fuel efficiency and resistance to fatigue. The manufacturing precision required to build these massive structures, with tolerances sometimes measured in fractions of a millimeter, is just astounding. It's like building a skyscraper that can also fly at 600 miles per hour. Then there's efficiency. With fuel prices being a major operational cost, airlines and manufacturers are obsessed with making planes as fuel efficient as possible. This drives innovation in engine design, as we talked about with high bypass turbofans, but it also means super slick aerodynamics. Those winglets you see on the tips of the wings, they're not just for looks. They reduce drag, improving fuel efficiency by several percent. Every little bit counts when you're flying millions of miles a year. Inside the cockpit, it's like a spaceship. Gone are the days of hundreds of analog dials and switches. Well, mostly. Modern flight decks feature glass cockpits with large digital displays showing all the critical flight information, navigation data, engine parameters, and system statuses. Fly-by-wire systems, pioneered by Airbus, replace traditional mechanical flight controls with electronic signals. Chapter 5. The future is now almost AI in the cockpit and autonomous skies. All right, we've seen how far we've come from those first tentative hops at Kitty Hawk to giant jets crisscrossing the globe, but what's next? If you've been following tech trends, you know AI and automation are changing everything, and aviation is no exception. We're talking about autonomous planes, folks. Yes, planes that can fly themselves, potentially without a human pilot in the cockpit. Sounds like science fiction, right? Well, it's closer than you might think. First off, let's be clear. Planes already have a ton of automation. Autopilot systems have been around for decades and are incredibly sophisticated. Modern autopilots can handle most phases of flight, from takeoff climb to cruising at altitude and even landing in certain conditions. Autoland systems are amazing. Pilots today often act more like systems managers and decision makers, especially during routine flight, than old-school stick-and-rudder aviators. So the jump to fully autonomous flight isn't as massive a leap from current capabilities as it might seem from, say, the Wright Flyer. The building blocks are largely there. We have advanced sensors, GPS navigation, sophisticated flight control computers, and data links for communication. The challenge lies in creating AI systems that can replicate and even exceed the judgment, adaptability, and problem-solving skills of an experienced human pilot, especially in unexpected or emergency situations. Several companies and research institutions are heavily invested in this. We're seeing autonomous cargo drones already in operation, delivering packages in remote areas. The military has been using unmanned aerial vehicles, UAVs or drones, for surveillance and other missions for years. The technology is maturing rapidly. The big question is, when will we see it in commercial passenger aviation? That's a much higher bar for obvious reasons. The potential benefits are pretty compelling. Autonomous systems could potentially enhance safety by reducing the chance of human error, which is a factor in a significant percentage of aviation accidents. They could optimize flight paths and fuel consumption with a level of precision humans can't match, leading to more efficient and environmentally friendly flights. Chapter 6. The sky's not the limit. So, from a 12-second hop on a windy beach to the possibility of AI gracefully landing a jumbo jet, what an incredible ride, right? We've seen how human ingenuity, a dash of daring, and a whole lot of science and engineering have completely transformed our world and our ability to connect with it. The journey of flight is a testament to our relentless desire to explore, to innovate, and to push the boundaries of what's possible. It really makes you wonder what the next 100 years will bring. The evolution from those early fragile aircraft to the sophisticated machines of today, and now looking towards an AI-driven future, is just staggering. Each step, from the Wright's perseverance to the jet engine's roar, the Concorde's fleeting supersonic dream, and the quiet efficiency of modern airliners, has built upon the last. And here at Zeta, we're super excited to be part of what comes next, exploring how technology continues to shape our skies. Thanks for watching. If you enjoyed this video, make sure to like, subscribe, and hit the bell icon for more fascinating insights into the world of technology and transportation. We've got so much more cool stuff to share with you. What do you think the next big leap in aviation will be? Let us know in the comments below. See you next time.